all I have to do. The good, there we go. Good thing is that Zoom is not as complicated and it is quite reliable. So pretty much, um, standard cookie cutter stuff. I'm going to start with, see, some of you, in fact, most of you have the background, basic background of what internet is about, but there are students who are actually not acquainted with the technology part. So we have few things that might appear as if, they're pretty much basic, but just bear with me on this, but I do have to go through them. One of the things I'm going to explain to start with, which is in the beginning, we are talking about the technology module, which is internet technology or the web search technology. So we'll just do some basics on that. Okay, so I'll start rolling the slides. Okay, in this one, we are just trying to explain how the internet is different from the browser and what are the different segments of the ecosystem that makes the internet. First of all, between 1, 2, and 3, you could see that it starts with the web application. Web application is basically something that is going to open in a browser environment, which displays itself only when it is connected to the internet, which means that more of the execution of the technology or the software that plays as a web application um, has least to do with the local machine and a lot to do with execution of processes in the cloud environment. That is the internet environment. So anyway, the basic thing that we want to differentiate is the difference between the communicator or the infrastructure that lets you get into the internet, which means the communication part or the first leg of your communication that starts with the bandwidth provider or anyone that gives you connection like AT&T, for instance. So AT&T is usually not considered as a main ISP or the internet service provider, but rather a bandwidth provider. Then we have number 5 right here, which is what we call ISP environment. So ISP is internet service provider that gives an added service or runs different softwares and provides hardware and support for hosting websites and related technologies that revolve around the website itself that is actually sitting on the web browsers as a service for the users in the ISP setups. Okay. So this is a totally different segment. Then we've got the sixth segment right here, which we call the actually the search engine environment, or these are what we call data center environments that has a lot of hardware and software connected through the network, but it's exclusive to the branding, such as Google, for instance. It would have its own data centers. Microsoft would have its own data centers that's running Bing browser with the uh, with the ability to exactly perform as Google does. And so those are the main search engines. Search engine itself is not just one entity, it is really a lot of data centers that are connected with each other, and each of these have um, several servers, or you could say an environment which is collecting the web pages and creating that indexing. The browser communication between, let's say, application 2 and 6, and say in the 2 where the user is using Chrome, um, they would be connecting to the Google environment or the Google search engine. And those data centers would be serving those pages that are all the time communicating with the local setup of a browser. A browser is a program which is sitting on a local machine or your local devices that are connected with the internet. And it is communicating with the search engine environment. Search engine is not a unity, or it's not just one entity again. It is a collection of a lot of services and design networks connecting several uh, hundreds of thousands of servers. So number 6 is separate from number 5, which is ISP, and it is separate from the communication or the first leg of communicator, which is the bandwidth provider. So that's just the basics. So, as we start to talk about the web pages themselves, how they are served or how they are collected or how they are indexed, we want these concepts to be differentiated or these segments to be identified as separate uh, areas of technology. So what happens in the data center over here, supposing it is a Google data center in number 6, it is sending out signals and it is sending out something we call robots, bots, crawlers. These are small programs that are actually going on to the ISP environments where the websites are held, and those websites are connected with the domains, obviously, and individually each domain has several pages which becomes visible through the browser. But at the time when you're accessing those pages, you are not connecting directly with the ISP. You are dealing with the search engine environment. For instance, if it is a Chrome, that is looking for the pages, or you have a query that you're running in a Chrome browser, it is coming to the data center where it has um, already indexed those pages which are constantly collected from the ISPs, or where the web pages or websites are held. So any communication or access that you get through number 4 is actually fetching the pages from number 6. Okay. So that's all we have to know for now. Okay. This is a simplified model of how the crawlers are going to the data centers and collecting web pages and indexing them. Uh, Not that we have to go into the details of what is said here on the left hand side. It's just the URL, and we will get to it later. But right now, on the right hand side where my cursor is moving, this is just showing these bugs. These are supposed to be crawlers or bots. Bots is not the good terminology to use, because bots are considered to be, or they've been given a to have a reputation where people are collecting uh, or scraping data, or bringing information um, through unauthorized means. So the best word is robots or crawlers. Okay. Now I want to introduce you to database differentiation between what is considered to be a search engine database versus the regular RDBM, RDBMS, or relational database management system. RDBMS has been around for a long time, and it still is used everywhere when you are dealing with internal environments, or where the databases are generally created for a specific application that is driven by data, and the data is actually it's a more of a structured data that is given attributes, or it has typically a relationship built between different data sets. So that is RDBMS, and as you could see on the left hand side, this is a model of simple RDBMS. Um, In this, we've got rows and columns, and relationship between rows and the data that is held inside of the row has got a sort of a relationship that allows for you to access different columns and different rows because of the relationship. It is given through queries that are structured through programming. So the relational database means that if you pull, let's say, an ID from a data cell right here, 1019, you can also pull the name of a person. With the name, you can also bring other information that is, so there is a string of information that can be pulled. And the relationship is not only horizontal, but it could be vertical and it could be diagonal. It just depends on how the database is programmed. So this is typically the kind of database we are used to using. But when it comes to search engine, things change a lot. And I want you to see how the database is different in terms of what is considered data sets. So if uh, you look at it from the linguistic perspective, it is going to make relationship between words. It is going to read the web page content through backend or where the HTML or the coding is done. The search engine is going to read the part which is in the coded format. It is not going to read what you see as a user. So when it is reading things inside of the codes, specifically in the HTML program, which is what makes those pages, or basically all the HTTPS protocols are linking to HTML pages. HTML is nothing but you already know what HTML is, I assume. So HTML program allows the search engine to identify the content or the language or the search phrases or keywords, anything that is held within what we call the HTML tags. And there are different kinds of tags. They are named tags, and naming is important for the search engine to identify with what type of content is held inside of them. For instance, if it is a title tag or a label that says that information held inside of that tag has to do with the title information of that page, then the search engine is going to look for or identify that content with the title itself as if it is the meta information or it is the type of information that identifies what the page is about. So that's the kind of intelligence it starts working with. Uh, to look for the data itself as if it is the language that has wordings, and individual words are identified as a single data set. So if it is like 20 words within the title, each of those words are considered individually as data or as a single data unit. Okay. And the relationship it builds on top of it is actually managed by algorithms so that it starts to make sense and collectively creates an intelligence that sort of mm, gives a logic to or gives an understanding of matching what the user is looking for. So I'm just explaining it without using the slide right now, so that the concept is clear. This slide on the right hand side is where my arrow is pointing, looks very complicated, but this is just a beginning for you to get an overview. But when I give you a deeper understanding, you will see how easy it is for you to grasp the idea behind what I just explained. Okay. So I'm not going to open up this site as the explanation slide. There are more slides which are easier for me to explain the concept. So I'm going to go to the next one. We will continue with this understanding that we are now looking into the search engine database, which is what we call a textual database. This is pretty much a repeat of what we just did. So RDBMS, if you still couldn't understand it, you could see that it has individual, let's say, in the RDBMS, if it's a student ID, we need to use to get information or more information or subsets of the main information. It is just going to find more as subsets of, let's say, student ID or a student name will give a course. The course will give another search or another ability for it to go deeper into finding more information, like if it's a degree course, non-degree, certificate, and so it continues. Um, on the right-hand side, we are looking at the search engine's textual database, which is what we just talked about. And this is more important for us. So let's look at these two words, market research. If these are the two words that needs to be matched as a search query, uh, it is going to look for the pages that has the two words included in the content. It is going to talk about, let's say, target markets, business strategy, and some of the other keywords that you may want to use. Each of these keywords as a single unit is considered single data, but market research, for instance, together will also be considered as a single unit of data just because it makes sense or it follows linguistically correctly and also makes sense in the way the search engine understands it or treats it as a more popular search term, not as a keyword, but now as a search term. So the search engine will start to look each of these words as a single data set or multiple data connected with each other, linguistically considered as a search phrase if it is more than one word, and it would give it another data unit, which means that the two or three, four words can also be combined together and considered as one single data set. So it has a lot of flexibility and a lot of ways in which the language can be maneuvered, combined together to give it a word sense. Basically, it's another technology which has a deep roots in the science of linguistics. Without going deeper into it, just think of search engine as having the ability to understand the language, um, and therefore the words themselves and their combinations are considered data sets. Um, in the RDBMS, the search moves in direction that allows you to go from one set or the one main information that leads to the next level of information, and so it starts to connect with each other in a different way, as if it is making a thread of some sort. But in the textual search, it's more of heuristic, you could say, or it is got that fuzzy logic of sorts. Basically, it is able to look at the entire content as if it is one whole data table, and within it, and it operates inside of that data table. And the data itself can be single keywords or it could be multiple search phrases. So it is sophisticated in that sense, but at the same time, it is faster, much more maneuverable, much flexible, and therefore, with in comparison, the textual database is to be understood as if this is where the query is going to look for and match things and bring those pages back to you. So having a little bit of a sense of what textual database is, that's what we are heading for. And subsequently, we will talk about semantics or the intelligence of language that the search engine applies. Um, and the semantic itself has a lot of attributes or a lot of depth that makes it faster and more, you could say, connected with the sense in which you are expressing your thoughts in words, or how you're putting your queries or words together in a search phrase. So that's semantics will have subsets or two sort of intelligence that we are particularly interested in. One is that in semantics, it has the ability to use what we call implied logic, or what the search engine considers that, or what it thinks of, or what it imposes, or how it interprets your intent behind the search phrase or whatever you have written in your search box. So that is an automated process, mechanically inclined. Um, and then the other aspect is of semantics is explicit part, where you have said something, defined something, or put something in your search phrases, but not quite complete, or might be expressed in a different sense, but the search engine is interpreting it differently. So to have that connect between the two express logic and what is implied logic, there are barriers, and we have to overcome those barriers in order to make it smooth, easier, and for the search engine to interpret your thought process or your intent the best it can. And this is where the search queries come in, where you are going to be able to overcome that implied barrier to give a better sense or give it more focused, um, you know, thought, or make it more, make it more easier for the search to translate. This is another slide which is going to explain now the different uh, sort of ways in which the search returns the search results. Um, I'm going to talk about the individual search result that comes on SERPs or SERP pages. SERPs are search engine result pages. And what you see as these different results that are displaying on the SERPs, individually, they are called snippets. Each of those snippet has got these three elements, one of which we call URL. This is what is showing right here. And the URL is actually not shown, as it doesn't appear to be a URL because it doesn't say HTTPS. But the fact is that if you put a cursor here, you would see, or if you click on it, you will see that the hierarchy of how these are separated with the arrow that's pointing on one side. There's one arrow here, one arrow here. That is actually replacing or simulating a backslash that you find in the URL. So it is actually a URL that is displaying. Under that, we've got a title part, which is the information pulled from the title tag of the HTML page. That is what this represents. Then we've got under this the description part. We call this description, which is, highlighting some of these wordings right here that you must have typed in your search. So all these lines in gray color are called description, and they're pulled from tag called description on those pages, which it will take you to when you click on this link. You will see that the page itself is got all these what you see in the description part written somewhere in the content. So, and there are much more complication in the description area, because some of the words you wouldn't even find in the description, even though the snippets is showing, but those words are not appearing. It doesn't mean that they won't be there. When you click on the link and you go through those pages, you will find it somewhere, because that's where the search engine will not make a mistake. So, um, and then there are different ways in which description part is obtained. So to have a good understanding of where this information is coming from, is pulled from that page, is also very important, because the idea obviously is that you want to be more proficient in figuring out which of these links to click on, and whether or not they're going to be useful. So whatever little information you get in the snippets will determine if you would take the next step and go to those pages. So we will see the mechanical part, or where these information sets are pulled from, so you can make a connect on whatever is displayed has some way of telling you whether or not to go to that page. Okay. Um, you don't need this. Okay. Here. Here is a good example. I would like to bring your attention to this area on the right hand side. Forget about what is on the left hand. That's just showing you how the pages are pulled. But what is important for us on the right is to, first of all, understand this illustration. This is the snippet, 3 elements. Now, this diagram is a little bit old, so you could see the snippets are somewhat not as they used to come before. Now it's changed. But anyway, this is the snippet. Then under this is a page that got pulled, which is where I'm putting my cursor. And what you're seeing here in the gray colored box as a separate coding, or something that is extracted from whatever is running, or whatever is responsible for bringing this page up. The coding, you will notice where the link or the title or the snippet's description is pulling its information. So if I go to this page here and I do right click and say open source code, you would see that the part that is displaying what you're seeing in the title part is held somewhere in the title tag. Where is the title tag? See right here, this is the title tag, and it's got exact information that is pulled and displayed on the snippet in the title part. You've got the URL part that is coming from base href. You've got the description part that is coming from a description tag. It should say meta name description. Now, what is being pulled and shown to you as a user in terms of snippet displayed exclusively are the meta information, or the information that is held in the kind of tags that we call meta tags. Meta tag means they are the giving more concise and more targeted information about that page. And that is why it's called meta information, or a meta tag that is holding a meta information about that page. So those are called meta tags. But the difference between what is shown here in the description tag, like AIRS is the words, this, whatever is written inside of it, this description is not coming in the description area all the time. There is more that gets displayed in the description area apart from the meta description tag. Okay. So at times when you are doing your search and you get this snippet, some of the information can relate to meta tags, and the others can be pulled from tags that are non-meta in nature. But we will get, and the reason why we are discovering things related to the tags is because when you use advanced search operators, you will have to make a decision on what type of information you need that can best be fetched by this particular advanced operator. For instance, if I use in title colon, I know where that information is going to come because I'm looking for meta information. If it is in text colon, then I'm looking at a more deeper text, or asking the search to do a more deeper search for information that possibly cannot be held inside of the title area, but has a better chance of being found in the text or or in the rest of the body of text, which is a deeper text. So I have to make that decision. At times, in title could be a better search operator to use, and there would be times when you want to use in text, and there would be queries where you want to use combination of both for two sets of information or two sets of search phrases or terms. So that is the reason behind learning or getting. So it's not about learning HTML. We're not here to learn programming, but the idea is to get a sense or enough about enough information to use your operators effectively, and with the conscious mind of understanding what would be returned when you use those operators. Generally, we take about 5-10 minutes or sometimes 10-15 minutes break in between, because it's a lot of information, and everybody needs a little bit of break just to digest all this. So why don't we take a short break right now, and as I come back in about, say, 5-10 minutes, we'll continue. You can make yourself some coffee, and if you have any questions and you feel that so far whatever we have covered, you have not understood any part of it, please put it in the chat box, or you can even open up the mic with just few people. So it shouldn't be a problem for us to be more interactive, and you can use your mic anytime. So let's say we take 10 minutes. I'm just going to shut my video and my voice. And as I come back, I'll turn both of these on. So I'll see you in a little bit.
Okay, see you soon.
All right, thank you.
Okay, thanks.
Oh, man.
Okay, I'm back, Mike, Justin, and James. Just let me know if you can hear me and you can see my screen, and I will continue with the lecture.
Yeah, looks good.
Okay, all is good. Now, this is more exciting, I think, for everyone. The curiosity behind what the indexing system is like and how the pages are actually read, and the process of indexing starts. This way we get a better understanding of what's under the hood, kind of, or whatever we are searching for, how that is held, or how that is organized by the search engine. This is the simplest way that I can explain it. So that's how the slides are made, and it's going to be very useful for you. It's like, if you have a place where you are holding something, that could be uh, would would require for you to organize it. In order for you to get it, you need a better organized cabinet, just like you have a filing system. So that's how the indexing works, primarily for it to make those pages easier for the search engine to communicate with the user, for it to match those um, search queries. So to begin with, let's look at how the whole process starts. There would be certain terms that I will use, and certain um, behind the scene technologies that we have not introduced yet, but I'd say it anyway, and then we'll connect with whatever I said. We'll proceed further and get into the details of it. So let's begin with this slide, which is the first process at the time of indexing when it is collecting those content pages. The example I'm showing is about this snippet. Let's suppose that and by the way, each of these snippets represent individual page, because that link which is going to take you to that page would only display one page at a time. So this snippet is representing, or it is something which the search engine brought back to you for you to look at. But uh, the way it had indexed this page is what I'm going to show you uh, in this box. Um, the search, first of all, is going to look for the title tag, and it is going to know what the page is about. So it would say becoming a certain. So this statement, or this search phrase is actually inside of a meta tag called title tag. So that is read first by the search engine. Second thing is, it is going to look for the meta description and try to make these as if they are the primary or the uh, overview information about the page. So that's the description part it's going to read. After that, it's going to look for the meta keywords. Okay, there is a tag called meta keywords or meta tag keywords in the HTML programming. But this part is not visible to the user. So this information is usually one of the kinds that the search engine is able to read, but the user doesn't get to see it. And then there could be other tags also that don't actually appear on the user side, or they don't show information in those tags on the user side, yet that information is always inside of those tags, like time and date, upload date, um, name of the author, and so on. So there could be many of the tags which you will get to learn later. And once you know of those tags, you can find a deeper set of info by querying inside of the HTML program. So a lot of times when you're doing, let's say, evidence collection, or you are, uh, let's say you are an editor, just like James, and you need to know where the story is coming from, or if the story is evolving or things are changing, then there could be different dates that don't usually get displayed, but you can extract it. At the same time, there would be, the kind of tags which are about multimedia, or about, the source of where that information is originally bought from. That part is also displayed inside of those tags, but are not all the time visible. And there are a lot of articles that are recycled. People, don't intentionally want to date them, and you don't see, who actually uploaded it when. And so there are reasons for what you can look for when you open up the non-visible text. Then the next set, for instance, over here, total words on the pages, words that have links to the pages, and then these are all algorithmic in nature, meaning that these numbers have a meaning for algorithms to find out, or to connect with the ranking algorithms. So for now, you can just read them, and you could see that what it is displaying collectively as number of, and everything is related to words. Everything has to do with the wordings, and nothing else. So this is the first part that the search is reading. Next is, it is going to extract all the content that is there in the, let's say, in the English language, for instance, this part, all of it is extracted from that page. And we are showing some of these wordings in red fonts, and there are others that are underlined. And this is for a reason. It's not what the search engine is doing, it's how I'm going to explain it to you what it means. So let's suppose that this is one of the examples, and this entire content is extracted without regards to the captions or the layout, or subheadings or paragraphing, nothing of that sort. It's just all the words that are extracted. Now, those that are in red color are the kind of words we call stop words, which means the search engine would disregard them as having a meaning for it to connect with or to relate to with whatever words are before or after. These stop words, unless you put them within quotation, which is another kind of operator that we are going to look for and talk about, which forces certain stop words to be recognized if they are within quotation marks. That is a method, but not what the search engine is doing. So at the time of indexing, it is separating stop words, and then it is also showing these words that you are looking, which are not underlined. These individually would have a meaning for the search only because they're popular enough, or they have a meaning that explains a lot more, in the sense of what could be understood by them in terms of, in the meaning of it. For instance, password, it knows what password is. Verification, it knows. Email address, it knows. Received, it knows. So all those that are not underlined are the words that individually can be considered as having a meaning for the search engine. What meaning it has for it is a different thing, but how the indexing system treats them has a logic behind, or it has a sense that it understands. So these are not underlined, but the ones that are underlined are the words that could have a meaning with their combination, if they are separated or they are connected. For instance, members management could be the word together, would have a meaning. Management team would have a meaning. Team volunteers would have a meaning, or volunteer can be connected with members, volunteers. So these combinations which are more common are the words which can connect with each other uh, in different ways and would not have a meaning as a single word, or would not have as much of an importance for the search engine to treat them as single words with a meaning. It would have to connect with other words, and therefore these are underlined. So this is a kind of um, they're linguistically complicated in how the search would treat them, not as a single word, but as combination of words. So the ones that are underlined would be those that requires combination or would like to have more words to connect with each other. Whereas these ones, for instance, this word at the top, account, is an individual word, would have a meaning. Password would have a meaning. So it will be very selective. So that's how it is going to start to make its own combination of words. After that, it is going to look at what is inside of the tags. For example, it is going to give importance or priorities of how they are set inside of the tags. For instance, there is a tag called H1 tag. Now, we are talking about the HTML language here. So H1 tag means that whenever you put H1 and you put information inside of it and you close H1, whatever is inside of H1 is considered as a main caption or a main heading. H2 is the tag that is a subheading to H1. And so it follows. After H2, there is H3. So the search knows at the time of indexing if uh, or it gives a higher ranking, or it matches the wordings with H tags. Starting with H1 as the highest important, H2 as the secondary, and then it continues. I think you can do as much as H7 up to H7 or H8. So this is one thing that it is going to do at the time of indexing. Another is the word density in terms of ranking the page as having more to do with whatever matching words have a higher density or higher occurrence on those pages would have a meaning. So let's suppose looking at the density analysis, just the word research came on was found 35 times, or 35 of the words research was on that page. So this is counting one words. So one word, internet 22 times, certification 13 times. This is the counts for that page for one word. And it would, we don't know how much of a depth it has or how deeper it goes, how many number of words it's going to count. But let's think of it as an example. Now, in the second, you could say in the second go, the search is also going to look for the combination of words that are more popular or can have a meaning which would give it a ranking if it has occurred together 10 times. So in terms of words or two words, we call more than one word when it's connected is called phrase. So it is 2 word phrases. Internet research, research specialist, internet research. So these are counted as 2 words, and then it goes as high as 3 words, nothing more. So as much as we know, it is ranking not more than 3 words at one time to give the attribute of density of words on that particular page. Okay, then it is also going to analyze non-linked words. These are linked words, meaning that these 2 words are linked to certain URLs. Okay. And then non-linked are not linked to certain URLs, meaning that the URL may not have these wordings. And like I said, don't mean to confuse you. There could be more layers that will give it a better explanation later on. But this is just a simulation of how the indexing system works to give you an idea of, eventually where the ranking brings those pages up to you. This is the formula, or this is the background of how it is done. There is a very high importance of the links that are present on those pages. You know, the links, obviously, there are different types of links. One that connect to the same domain and basically run inside of the website or the domain itself. There could be others that are linked outside of the website, taking you somewhere else, and so on. So the links have a more of you could say utilization of search when the words inside of those links, which are representing the domain, these folders, the subfolders, and the web page itself, giving it a path to take you to those pages. Each of those words, a combination of those words that make it into the URL, would be useful when you're doing searches for the links themselves. Why you do that is, again, like, we are going to look at why we do searches for the words inside of the links and what is their utilization. But at the time of indexing, it has a lot of importance for the search engine to separate the type of links, or the type of links that it's separating needs to connect with the wordings that it represents. For instance, um, just take randomly anything. Over here, there is a link association.org/AOFIRS-management-team. It is actually connected to, or it has a meta tag inside of the title that represents a page named management team. So there is this combination. It has a utilization for the search to use these two sets of info to match with and connect with anything to do with AIDS Association management team. So not that we have to remember all that we are discussing right now. It's not a big deal in the exam. It's not coming in the exam. This is just for your understanding, to know how everything is organized at the time the indexing starts to happen. And the second aspect is that you understand that whatever is read by the search engine, is different from what you get to see as a user. So there is this distinction. And when it is reading the HTML page and the tags that are holding that information. Rest of it is not as important. The idea was important. That's what we were able to get to. This is where I'm going to show you the information inside of the HTML page. Now, even before I do that, why don't I show you the actual source code, which you can easily get to see just by running any website. Let's suppose we use AOFIRS.org, and I go to my website and I click on, let's say, membership. And associate membership. So we are on the page that is named membership benefits. As you can see with the last backslash, we have whatever follows after is actually the name of the page. So the name is membership benefits. And this is what you're seeing right here. But supposing I want to look at the source code, I'm going to just put my cursor anywhere on this page, go right click, and I'm going to click on something here in the drop box called, in the drop down called view page source. So what happens is that it opens up, shows you the HTML coding, and inside of this, there is a lot of complications with there's so many lines in there, but you don't have to worry about it, because if you want to find something that you readily want to look at, you can just do Control F here. And let's suppose I use keyword here, and it would just highlight itself, and I can see my keywords are inside of this tag, which starts like this, meta name keywords, and ends with the backslash right here. So whatever is inside of it, I'm sorry, this one. So backslash and again greater than this sign, which means that whatever is held inside of it is the content, is what the search engine will be reading with reference to the keywords. Okay. So coming back to the slide again, I want to run this to show you. So the link is pulled from the href, title right here, description right here. So we know that already. But the better part of understanding of how these tags are important and useful, here is where I would want you to focus on when I run this slide. As you know, the search engine is collecting only the web pages, and it is reading the content, and therefore individual web page, before it gets indexed, we need to understand the different layers or different areas of information on those pages that can communicate with the type of operators you're using. And for you to know that, you have to understand what are the different areas and what could be the different areas of a web page, and how much of the information is inside of those. So you can query it with forcing the search through those operators to look into that specific part of the content page. Okay. Typically, the page itself has a header, which is where you see the logo and you see the top link. Sometimes you see the search bar at the top, and few other information. But the portion that is shown here at the top is the header of this page. And the next part is what we call the body of text, which is the middle part. And I don't know if you noticed, but anytime you are on a website, mostly what changes or what brings the information for display is the middle portion, or the belly of it, or the body of text. Okay, this is middle portion we call body of text. The top portion remains intact and it doesn't change much. What changes is the body of text, and even the footer remains constant. And what is footer? Footer is this part right here. So when we are querying the header or the meta tag title, or where we are using in title, we are querying those pages that have to do with that special information inside of that title tag. And those information sets are usually very short, concise, and not as wordy. And typically the information which talks about the page itself, which gives in a concise form what the page is going to be about. That's all. So that is a limited information we can get, and that limited information runs behind the header portion. Remember when we were doing the learning, looking at the indexing, whatever tags that we looked at, initially there was a title tag, there is a description tag. All those informations at the meta level are actually running in the code form behind the header, and that information is what is bringing, or that coding part of the header is making this header display in front of the user. So in other sense, what I'm saying is that the header is usually contains meta information. Okay. But what runs in the belly, or where you're doing in-depth search for the content itself, it could be one para, or it could be number of paras with some information, or some of the some of the search phrases in one para, some in the second, some in the third, but collectively, it would be all those three different search phrases you want to be found on that specific page you're looking for. So for it to be found, you will do a search in the body of text, or in the belly of it, in the middle of it. That means you're doing in-depth search, and not just looking for the title pages, or the pages that has that info in the limited form in the title part. So this is the body. Now, what body usually contains, as you could see, it contains headings, it contains main caption, subheadings, it even has images, it has a list of documents like PDF, for instance. PDF documents can be listed here. We don't have to run the command file type colon whatever PDF to get to it. If we can use the words, or the search phrase, or titles, or captions, we can get to this page, and it would have a more detailed information on it for you to navigate further from this page. But to get to this page, you would have to understand that the tags that what we call non-meta tags are running under the header, or inside of the body of text. And those non-meta tags include H1, which I showed you before, H2. There could be other tags that I'll show you as well that are running in the body. And that's where we are going to use an operator called in-text colon. But let's see as an example, what are those non-meta tags. In the footer portion, usually there are a lot of links. There is, contact, there is typical information. So the footer is also constant. It remains the same throughout the navigation that you do for that particular domain. You would find uh, usually you will find that the footer and the header would remain constant. Okay. So let's go and see what is considered meta and non-meta tags. Now, what we extracted from the same search, or this snippet, on the left, you could see that, remember where we looked at the header part? For this header part to appear, and for whatever code is running behind it, is shown in this box. You could see that the header portion would have these type of info: keywords, author name, description, title, but these are meta tags, okay, mostly. The non-meta tags, which are of interest at the time of indexing for the search to differentiate and organize, are H1, H2, which is talking about main caption, subheadings, and so on. It is also going to give emphasis to the tag, which is named time. So time and date is strong for the emphasis on the text. If you have used strong as a tag to put a statement or something in it, it would consider it to have a value because you have emphasized it. So it has a way of thinking, which is again mechanically programmed to recognize some of these meta tags as having more relevance than others, or one having more precedence of another over another. We would never know that because we don't know exact algorithms, but we do have a sense or idea of what if these are given importance. There is a P tag, which is paragraph related tag. It has an importance for the search to match the captions or the H1s with P. Anything that is followed after the paragraph, or I'm sorry, after the caption, like H1, H2, that has the P tag or bunch of lines as a para or some more detailed information, would have will have to make a relationship with the captions or the main tag or the main uh, heading. Why? Because people do what we call keyword stuffing. So they create intentionally for higher ranking main captions or headings which carry those keywords, but the paragraph has nothing to do with it or the relationship is not established. So there is another reason for the search engine to differentiate it as a stuffing of keywords for SEO purposes, or if it is a quality content or not, or it has established relationships. So that is another reason why P and H has relationship. Going down, we've got caption. Now these are different HTML upgrades have brought in all sorts of non-meta tags, which are now either the names are changed or they've become more I guess more granular. But anyway, what is another sort of info which generally you don't get displayed on the user side is a tag or inside of a tag called source. There is video files which are inside of the tag called videos. So all these non-meta tags are held or are responsible for presenting content inside of the body of text, and they are separated at the time of indexing for it to react with or act with the operator like in-text along with other Boolean operators and other supportive operators. So that is the reason behind. Here on the right hand side, we have shown some of the advanced operators that actually work on these information sets. For instance, in URL will look for the URL in the header portion, as well as it will look at all the URLs that are inside of that page in the body of text, as well as in the footer portion of it. If you do in text, it is only going to deal with the only thing that it will look for in the first instance is description, but it will go beyond that because it will so the only thing that or the only tag it will query in the header portion is the description meta tag, but it will then go down into the non-meta tag portion and search into each and every non-meta tag inside of the body, which means it is capable of doing a deeper search for the words. If they are not found in the description, it will go deeper. But if you had used in title, for instance, it would only look into the title tag and nothing else. It wouldn't react or compare or go deeper into the body of text. It will only stick to that limited information inside of the code running behind the header, specific to the title tag only. So this is just giving you us an idea about the tags that are running, something that I've already explained, like in the header part, it is going to look for, description tag, body, link, header, and so on. So anything that is behind this blue line is specific to header, and whatever is behind the red line are some of the examples of the tags that are in the non-meta or the body of the page. So these slides are important only if you are preparing for the exam and you need short notes. Basically, it's somewhat exactly what we have explained. Like this one, for instance, these are meta tags. So to describe what meta tags are, or if in the exam they ask, if you can differentiate between meta and non-meta tags, this slide can be useful. Like meta name description is a meta tag, meta name keywords, meta name title. Uh, in this slide, you could see that in title is querying information held inside of the title tag. So what the title tag looks like is what is shown here. Typically, it starts with like this, less than and greater than, and then ends with a backslash. So whatever is written inside of it as number of words or search or the phrases is coming or is being queried by the in title or all in title. The title element, what is important really here is to understand that when you're using title in title colon, the importance of it is because you want to look for those pages at a meta level, or just to get an idea, or just running something that is looking for the idea about something, or if you know of a title, specific title, you can look for it. But there is not a lot many words that are used in it, meaning that if you're going to put a very long set of words, or if it's a very long search phrase and you think it is going to be found using in title, probably not, because there is some sort of embargo, or you can say that there is a restriction to the number of words that you should put inside of title tags coming from and that's coming from Google itself, or all main search engines pretty much are unified in how they would organize or direct the uh, the programmers or designers of the sites to maintain certain certain maintain certain restrictions, or there are rules and guidelines for them to stick um, to their expectations of rules of how they should design their sites. And if they don't do it the way they like it, it's probably going to be dropped, and it's never going to show up on the website. So that's why there is always a limitation, and an in title is limited to number of words which should not exceed. There is a list of it, and I'll show you. Usually, it's not more than 20 words, or there is a number of characters that you cannot go beyond. So that is a list that you can look at later. Therefore, whenever you're using title in title colon as an advanced search, you need to be careful about number of words that you want to search for. Then in URL, for instance, this one, for instance, just to give you an example, if it is to search for something inside of AIRSassociation.org, it would treat AIRSassociation.org as a word and not as a domain when you're using in URL or you're using an advanced query with in URL. It is going to treat the entire URL as set of words, with the exception of HTTPS colon and backslashes, and even www is ignored. But if it is AIRS Association alone without .org, it would think of it as a word. Even if you use it as a domain, AIRSassociation.org, still it is considered a word. And what follows, or whatever is part of the URL coming, let's say, after the first backslash, it says CIRS certification and benefits. These all will be treated as words for matching purposes if you're using in URL. So we'll get to that later, but it is just something that you should be aware of in order for you to understand how the operators are going to recognize and match, and where it is going to match those tags which are behind the content pages. And in text, again, it is giving you this example. So If there is a question in the exam that asks if these tags or these non-meta tags, H1, H2, all of these, do they get queried when you're using in title versus in text, you would know better and you would be able to differentiate. So the language search understands, okay, HTML, what is the advantage of it? By now you would get the understanding or at least have a sense of what is the advantage of knowing HTML. Not the programming language, but some of the reason why you would want it to have a meaning for the search operators to work on, only to that extent. So there is importance of HTML. It is more on the theory side where you can just look at these and prepare for your exam purposes. That's why they're there. And that should finish up the technology part where I feel that you have a better understanding by now of how the indexing system works and how the tags are read and why we need to uh, we need to use certain type of operators to find that specific information on those content pages. So the next thing we will be looking at is intent and context recognition. Now, thing about intent and context, whenever we make our search queries, to our best understanding, we do like to put all the words in the correct sequence to make it into a phrase that could be understood better by the search. And that is only our thinking. Like this is, one of the ways in which you can say that there is something called consensus ad idiom, like meeting of minds between what is mechanically done and how you understand it and how you put it, and your expectation versus somebody else who would put the same idea but word it differently. Yet you would have the expectation that the search engine would understand it in the same sense, where two of you have used different wordings and still the search is given that task. And there is this disconnect because of it. Sometimes our expectations are much higher. So for us to be more careful and be mindful in how we are going to phrase certain queries and to know to what extent it would understand it, even if it's in the simplest English or in the simplest wording, which cannot be changed or which is guaranteed to have only one meaning. Um, Yet there would be a part where the search engine would add to what you have described or put in your search as words, um, to give it a sense or give it a context on its own, on certain assumptions, only because it is programmed as such or it is designed. And remember, it is the best that the search can do with given the limitations of the algorithms it has to work with. So it would add another additional ingredient we call context. And whatever is added as context by the search engine, there's a term we use. We call it um, an implied context, which is not really what you've expressed, but a part where the search adds to what you have expressed from its own wisdom. That's what we are going to talk about in order for us to better understand the brain of the search engine and how we can make that connect. And if there is barriers or there is a disconnect or there is some limitations, how we can overcome it by forcing the search to do exactly how we say it and limit its own implied wisdom to be connected or added or imposed on what we are asking. So that's the idea. That's where we are going to talk about intent and context recognition. So starting with some limitations and how semantics is linguistic intelligence that works on textual database. It is pre-programmed, it's flexible, it runs with algorithmic background of you know where we use a Boolean logics to connect words, and there would be some other ways in which the linguistic science has evolved and added ingredients such as um, what comes with the intelligence as a formal semantics, as a lexical semantics, and conceptual semantics. I've dealt with these because I've actually I've done some algorithms and worked on one section of the formal semantics. So I know how profound and how complex it can get. But the way in which we distinguish it into three elements um, will give you an idea, but not exactly how it works. Okay. So one of the things we deal with in terms of those who have a linguistic science background would understand it better. But there is something called formal semantics, then there is lexical semantics, and there's conceptual semantics. As it is explained right here, and you can read through it, formal semantics give a sense reference, or it has a context, or it has something that comes from experience that is added to give a sense to the combination of words when they're put together. Of course, they have to be linguistically correct. They have to be, you know, they have to have sense or make sense in the language in which you're writing. So that is formal semantics, and it is based on giving sense to what you mean. Sometimes there is there is the formal semantic is pure English, for example. Then you've got a British English, you've got a US English, then you've got a certain slang words, certain words that are evolving, coming becoming more recognized. So you use something called formal semantics, which is standard semantics in a sense. Then there is a literal meaning given to individual words, which we call lexical semantics. It is hardwired, or it is considered to be running at the top layer. Then we've got conceptual semantic, which gives cognitive structure, which means it goes beyond the formal semantics. It could be, certain phrases that are evolving, but with relationship to what, in what situation. So that is cognitive structure of meaning. That's all we got to know. But just so that you understand that semantics itself, or the intelligence of language, is got a lot of branches, and it has subsets of complications that we would like to consider as sections or areas of further study. So textual semantics is what is running on top of everything that is collected um, as a content of pages that are being indexed. So that is the top layer, or the textual semantic we are dealing with. Now, in the sense of how we can explain how the search engine would interpret your search queries if they are worded correctly in correct English. Certain type of intelligence, the semantics would apply on its own to give it a meaning which is not really an implied meaning in the sense of it being imposed, but rather it is a meaning which you probably did not complete, or left it as an information that can easily be interpreted by the search engine, because it is logically mm, uh, and I'll explain it even better when you understand what stemming is. There is a process called stemming, which is where the technology itself, or the automatic system, kicks in, and it gives you search results for, and it may give you wrong results only because it is doing stemming. But mainly say 95% because of the stemming process, the meaning doesn't change. The words might change as singular, plural, or they may default back to the core word or the base word or the root word. So in case you have used, say, cheapest with cheaper, you know that it may not have made sense, or it may not have appeared as comparable or is matchable in the content pages. Yet the search is able to find a root word for it that would match or would become part of that phrase, or in a way, it is rephrasing it to change the word cheaper or cheapest to, let's say, cheap. So it would know that the word cheap is the root word, and everything that is coming out of it as a derivative of it could be cheaper, cheapen, but it would not be a word that is replaced. It is not a word that is substituting another word. So stemming is purely defaulting that to the root word in order for it to get a better understanding. That's when we are talking about search engine's brain, not as a user. So the search engine is doing stemming. Then there is another process called lemmatization, which means now it is also able to substitute the words or find something which, without changing the meaning or the sense of how you are expressing your idea or how you're phrasing your search terms, it would understand the meaning behind it, or by replacing it with a better word or other words that are commonly searched along with the idea that you're expressing, so that the search is able to bring something back and not come empty handed. It is going to do a lemmatization process. Lemmatization example is also somewhere here. Like wake, it means to wake up, or vigil or funeral. So it would have to make a sense and understand it, as if it is not making sense along with other words, it would give it another meaning, or it would get a derivative meaning of something that is a substitute word or a better word. So it is going to use synonyms and so on. So that is stemming and lemmatization. Reason why we are dealing with this right now is because you want to be mindful while you're typing your search queries, that it would give you a room for error to a certain extent, only because it is doing stemming and lemmatization, and moreover it is substituting uh, that search query or the search term with something that could be its derivative or a substitute. It can even understand certain ideas or certain type of alpha numeric numbers or numerics to relate to something which it has collected as as an organized directory. For instance, if you use 92385, these 5 digits, it would know that it is an area code for Orlando. So whenever you're doing 32835, it would assume that it is a postal code. um, we call it a postal code, or if it's a zip code. If you are writing 407, it would know that it is an area code. So it is the wisdom or the machine learning that is actually responsible for, or um, mm, giving a little bit of a support for stemming process to uh, relate to or connect those with an understanding that it has a meaning for. So if you didn't put zip and 32835, but it's just the number, it would know it's a number. If you just put the word zip, it would know you're looking for zip codes. If you are using, anyway, there'll be a few more examples I'll run. But right now, I'm going to talk about one more aspect which previously was not part of the algorithmic process in Google or even other search engines. There was something called ontology. This is another science that evolved, or another way in which linguistics got beyond its capacity to just stick to the language part. It went beyond because of the big data or the raw data that is easily available now because of social media interactions, and so much more is coming up that's visibly available on the internet. What those data sets or raw data or scattered data we used to call big data. Even today, it's a big data, but thing is that not much is being done for the user's benefit. It is mostly for marketing, analysis, trends, and those kind of things. But for the search engine to use ontology means that it would start making relationship with those data sets, because they are connecting, or they are somewhat connected with each other, uh, in terms of its relationship, in terms of business together, in terms of friends and family, in terms of what is frequented by you on the search, and so on. So these sets starts to appear and create an ontology of sorts, which the search engine is now capturing and using for several different reasons. For example, it could be a relationship between an individual and an entity, or it could be a relationship between a human being and let's say their preferences, or a relationship between family and friends, and so on. And it could be anything that is frequently been browsed or used uh, within the social media, as well as all that information which is collected while you're using utilities connected to your browser. As say, you've got what I mean, utilities. There's several that you can talk about. um, the image searches that you are doing, the I guess the calendars you're using, the Gmail account you're using, and everything that is being used as a facility given to you on the condition of certain privacies that would, that you have a control over others that you don't have control over, and those that are conditionally um, used by the search engine, um, for the reason of ontology, or for connecting it with for something that may not, or you may not think that it has to do with you directly, but indirectly it would have a relationship with products or services or something. That all of it, that relationship that was not there before, is now being created by ontology, meaning that it is another set of intelligence that now the search engine is using in order for you to connect quickly. It is not autofill forms or anything that you used to think as the only set of information collected, but goes beyond it. The example of ontology is actually shown in this slide. Taking an example of Simpsons, for instance, you could see that there is a relationship between siblings and their pets, um, mother and son, mother and daughter, and so on. So even those are considered to be the information sets that are now part of the search engine's database, or their way of how, if you've done some incomplete search, or your search phrase is mentioning something about siblings or your brothers or sisters, it would know where they are. It would just, start to bring the information back that connects you with them. But there are triggers, or there are ways in which it would understand that you are now seeking, or the search engine now has to use the ontological algorithms to connect you with them. So all for or all in the uh, in how they phrase it, for better user experience. Okay. it's really intrusion of your privacy, and really a lot more is exposed. And they call it better user experience. Anyway, so we want to go further with giving more examples of semantics. Um, for instance, and by the way, we use semantics sometimes to find certain information which otherwise, we would think that is lost, or something that, we want to um, look for, and we let the search engine use its own suggestions or its own implied wisdom to find that for us. So there are ways to do that also, taking advantage, um, being on the other side of the fence, like as a user, we want to take advantage of ontology to find something or someone or our lost friend and things like that. But here, let's suppose we want to give an example of another semantic similar to the the zip codes I talked about. Another semantics in play you could see is with this example. For example, let's not worry about in title colon. Let's just focus on these words we've put in the search box. So if I wrote John Turner Carpenter wood shop brochure, you know what I'm trying to look for. I'm looking for a brochure for a carpenter named John Turner who has a wood shop. That's what I'm looking for. So when I run this query, I find that the word brochure is, and these are the search results, by the way. In the first one that I'm pointing to is replace the word brochure with the word catalog. In the second one, the word woodworking has very conveniently been replaced as a word that would mean the same as woodshop. Pamphlet instead of brochure. Woodworking is another semantic example. Carpenter's shop is another one. So it is doing semantics. It is doing stemming and lemmatization process right now. The word flyer is used here. Store, workshop. Now, the only ambiguity or anything that would make it more difficult uh, is words like wood, for example. James Wood could be a name. So because wood is could be a name, it brought an incorrect result. So we have ways to overcome this situation. We can put the wordings John Turner within quotation marks and wood shop within quotes also. Anyway, we're not getting to that, but I'm just showing you some of the ways in which it can go wrong also. But stemming and lemmatization within these red boundaries, you could see these words. Another example, Beth Mary Jones is the name. Beth, it would know automatically that it is a short form of a Christian name, Elizabeth. So it would just substitute it on its own. This is another example of semantics. How is everybody doing so far? Hi. All good for James, Mike, and Justin so far? Still interesting, or is it
Yeah,
useful?
very much so for me. It's great to be going into this extra depth. It's new territory for me and providing some great context.
Thank you. I'm glad to hear that. I'm not sure if Justin is doing okay.
Oh yeah, doing
How's
fine. I
doing
mean,
fine?
some of this,
Good.
some of
No
this I heard
headache yet.
over-
Mm.
Oh,
Yeah.
No, I've got a headache just talking so much.
Oh, no,
Okay.
no.
Anyway, I think it's useful. It's a lot of information, but remember we are talking about CIRS course, and given the fact that we have a certain standardized structure of how we would like to see CIRS credentials to have the depth of information that we expect. This is a lot of info, and after we get done with this course, you'd find that you have this extra confidence to know exactly what, not only what you're doing, and obviously finding better results and things of that sort. But you would, if you'd like to go independent and do your own research work, I think this course will do you a lot of good, um, because it would help you to understand the brains of how the search engine is reacting to how to your search queries, and you would be mindful of knowing um, you know uh, before even putting those queries together, you would know how to organize your queries. That's like understanding the brain of somebody to know how to talk to them and how to convince it or how to make certain things happen your way. So it is a communication, I think, which between the machine and the humans, that's where you would feel comfortable. um, so hopefully it's going to be more useful at the end. Textual query and natural language recognition. These are some of the, see, there is this thing called natural language recognition, and these are all coming or evolving after the search engines started to run those indexing algorithms. Everything was about language, but very hard to control um, the sense of how the language is interpreted. Especially, it's not just dealing with the English language, remember, it is dealing with all sorts. And then there are certain ways in which it is going to deal with the barriers that are intact or remains as part and parcel of the language limitations. So once we know what the limitations are, we would also be able to foresee and foretell in our structures of our search queries of where the search will falter or where we may not be able to get what we require. So it will, so that's the sense we will get after learning these things. One of the things about one of the things is beyond that, this is beyond lexical part. This is more to do with the uh, language recognition. Here, it is used in a different sense. Sometimes we use natural language recognition as text, translating text to speech and speech to text and so on. But in the way we have used it here for the search engine is to understand that it is mapping or it is something that relates to the machine learning or experience of what it has learned from how people are doing searching, and to understand what is more frequently used as a preferred language or preferred search phrases. It is creating its own, it is marking its own um, dots and connecting them, and hard coding it automatically. So that is the process which sometimes we cannot bypass, but we use algorithms to twist it, optimize it, change it, that kind of thing we keep doing to improve the or let's say if it has made some wrong connected connections, or it has learned something which is not as accurate, then these are always corrected through algorithms by forcing them into understanding it in a different way. So because it is automatically created, it becomes a barrier a lot of times. One of the barriers is a lexical barrier, which is natural and which is very difficult sometimes for the, even though you've programmed it as best as you can, but it may get confused. For example, it may treat the word board as a noun or as a word. like if I'm boarding, or if it is a board, or if it is, a physical board of some sort. Then we've got syntax level barrier. A sentence can be parsed in different ways. For example, he lifted the beetle with a red cap, or did he use, I mean, I don't want to read something that is already in front of you. So I guess what it is how you have phrased it. So syntax, like where you have used before, the words before, or before certain words, after certain words, or I guess how you have spelled it might be a syntax level barrier. Then there is referential barrier also. Now these barriers are inherent; they'll always be there. It's very hard to change them. So we have to understand it as we write something. We have to give it a thought, or give it a few seconds to know that there could be these natural language interpretation barriers, and therefore, or we can, based on the search results we are getting, we would be able to pick that as a cue to know it. We may have to change it or phrase it differently. So those are the barriers you have to deal with. Referential barriers, the naming of these, like what is the difference between lexical versus syntax versus referential barrier, is only important for the exams. But when you're doing your searches, you just need a general idea of what could be the natural language limitations. Um, that's why I'm all the time telling you that some of these terms are important, but for the exams. And it's not rocket science. We could just get an idea. Referential, something that has a reference to, for example, Jane went to John. She said, "I'm tired." Exactly who is tired? So there's a referential barrier, like who are we talking about? It could be confusing. Syntax level, I told you how you spell it. Lexical is core words that could have different meanings. So keep that in mind, that these are some of the barriers and limitations we have to deal with, and we have to be mindful of. So no matter how much I tell you about, phrasing something, putting keywords, or selection of the best keywords, or using the best operators, but if you don't have a sense, or cannot foresee, or understand the limitations of how it can be interpreted differently by the search engine, it wouldn't do us any good. So that's what we have to be mindful about. And this is the reason we are doing all this. Machine learning, I told you, it's learned something. It's from its experience, from a number of ways certain wordings are combined. Some words are used in combination with others to give it a meaning, to find something, to know something, to in whatever sense you've used those. But they eventually end up becoming part of the learned intelligence, and become hard coded automatically, as if it is a repeat action, or it is more popular action, or it is more sought after action. It just starts to run. It's automated process, okay, for connecting the dots. And because it's automatic, that means it is a barrier also. And at times it could be counterproductive, or it could be learned, um, in a biased way. And identification of spam or duplicate contents. Yeah. Patterns, queries, detection, spam, duplicate content, stop words, but it's not as important for us as someone who is doing searches, but more important for anyone who is um, mm, who's building the algorithms. That's a headache that I had to go through. MLI is for me is no good, really. It's just a shortcut to get things done in a in a simpler, in the more automated way, but it compromises on quality of results. Anyway, apart from that, we are going to start with the textual semantics by looking at some of the ways in which search actually applies it. What could be the attributes, or what the defined limitations or bias that the search engine is going to impose on your search query. So this is a subject in itself, and we are going to go through it in our next session. And this is where I'm going to start with from this slide. And I'm sure we are meeting day after, which is Wednesday. And let's see. So we have a class on Wednesday. So Mike, when are you going for that short vacation of its sort? I don't know if it's a vacation or just heading to Toledo.
Well, that's we're just going to go back home, see
Oh,
family and
that's your
such. But
hometown.
yeah, we're going to be leaving
Hmm.
like September 5th, and we should be back by the 16th, which is a Tuesday to a Saturday. So
Okay. So, I'd get to see you on Wednesdays, next class, which is day after.
oh yeah, you
Mm.
see my smiling face, maybe. I don't know about seeing my face.
Well, you're smiling because you're going back to Toledo.
Oh no, I'm smiling because I'm learning so much stuff here. Now I'm going to
Yeah.
talk to you more about that natural language.
Yeah, for sure. Yeah. I mean, it's unfortunate for us, like we are so much limit. Even now, 2 hours is quite a bit of time for
Yes.
learning and for anything new to be absorbed with so much being talked about. It's it's an effort, I would say, for all of you, especially whoever, and I'm sure many of you are working, long hours or whole day, starting early mornings, coming in the evening, and getting this headache. So hopefully, it's not going to be too boring or too stressful. And I hope to see you in all my classes. James just joined us, so I would encourage him to, if he enjoyed the lecture and if he thought it's not a headache for him, let's meet again day after, and let's be more consistent on the for being in the class, because um, as is, we don't have we are missing 5 of the students, and I'm going to send them an email today. So it would be nice to have at least 3 of you in the class, with the exception, of course, Mike, when you have to go, you got to go. Okay. All right, so let's call it an evening, and hope to see you day after. And by the way, James, where are you in US?
Well,
Which part of you?
so I'm Australian, and in fact, I'm joining you
Okay.
today from Sydney, Australia, but I do live in the States. I'm here for a
Mhm.
few weeks. I'm based in Albuquerque, New Mexico.
Okay, New Mexico, right.
Yeah,
So
but
that's when are
the
you
time
coming back?
zone. Sorry, so go ahead.
When are you coming back?
I come
Back to
back
States.
mid-September, so I'll be joining you predominantly from Australia, but the time zone actually works okay. I'll join you at 8 a.m. in the morning here, so I'll actually be starting fresher than everyone else, perhaps.
You betcha.
Oh yeah, for sure. It's early morning for you,
I'm a
and it's
morning
a very
person
late
too,
night.
James.
Livinus, if I'm saying it correctly, just joined us probably before. I just noticed. Livinus, are you online? Do you have a mic you can use? All right. So I have him registered from Nigeria. Um, so I don't even, I mean, I'm not sure if I'm pronouncing it correct, and I'm not even sure if it's a guy or a gal. So sorry about that. In any case, hope to hear from you, because I can't, your mic is closed. And by the way, um, day after tomorrow. And by the way, I'm in Turkey right now, just so you know.
Yeah.
I'm in Antalya. The instructor who is supposed to be teaching you, he wasn't well, so I took over, and I was on my vacation, sort of in Antalya. You know where Antalya is in Turkey? It's in the southern part, the Mediterranean part of Turkey. And the time right now with me here is 3 a.m.
Oh,
God.
Early morning.
Oh, God.
So I beat all of you
Wow.
as far as the timing. The worst of the worst is for me, but I'm okay. I'm fresh. I did sleep quite well. So anyway, not taking much of your time. Thank you so much for attending. I am so happy all four of you are here now that Levinus has joined us. And good luck and see you day after. Thank you.
okay.
Bye
Thanks.
bye for now.
Yeah,
Bye,
have a good
everyone.
Take care.
weekend.
Bye bye.
Bye.
Okay.